Today we're going to be talking about limits, but we're not just going to be talking about limits in general. We're going to be talking about evaluating limits analytically. You've already probably talked in your Calculus 1 class about solving limits graphically and numerically before, and you're currently stuck on trying to find out how to evaluate limits analytically. So in this video we're going to be talking about how to solve those limits analytically. So here we have our very first problem. We have the limit as x approaches -1 of x squared minus 1 over x plus 1. So when we are looking at this problem, we're looking to see, okay, are we able to just go ahead and plug and chug like we did before when we were solving for the limit numerically? Well, we can try that real quick. We can go ahead and put in -1 squared minus 1 over -1 plus 1. So when we square -1, we get 1, a positive 1, and then we subtract the one that was already in the problem, and then we get over 0. Let's just continue going to see what we actually get. We get 0 over 0. Alright, so when you get 0 divided by 0, you get what's known as an indeterminate form. An indeterminate form basically means that there is a hole in the graph at where x is approaching in the limit. So in this case, when you are graphing the equation x squared minus 1 over x plus 1, you'll be able to see that there is a hole at x equals -1. So we did it numerically. I talked about it being done in graphically, where you'll see just a normal line graphed, but at x equals -1, you'll see a hole there because there will be no y value since it's an indeterminate form. So what we need to do is we need to simplify the x squared minus 1 over x plus 1. We need to find a way to get that function into a simpler form so we can actually solve for the limit. So what is it that we need to do? Let's go ahead and simplify it down. So in order to actually simplify down the function, we need to include the limit with it. Because if we were to just continue it out just algebraically without using the limit, the whole function and work will be done wrong. And on your exam or test, your professor will most likely take off points because you didn't include the limit, and most likely will give you a 0 for that problem. So let me show you how to actually do it analytically. You need to first write an equal sign, and you need to write the limit as x approaches -1 of, so how can we expand x squared minus 1? So we can just easily write x plus 1, x minus 1, like so, over, we can't really expand x plus 1 because x plus 1 is just x plus 1. So we just write x plus 1. Alright, so is there anything that we can do to actually simplify it down anymore? Yes, we can. Since on the numerator you're able to, so in the numerator there is a multiplicating factor of x plus 1 quantity times the quantity of x minus 1. So with that you can cancel out the numerator and the denominator since they're the same thing. So x plus 1 on the top gets cancelled out, x plus 1 on the bottom gets cancelled out. What does that give you? It gives you the limit as x approaches -1 of x minus 1. Alright, so now you are now able to solve it numerically. Solve the limit numerically, where you can just plug in -1 into where x is. So -1 minus 1 is -2. So to write it, I'll just write it down here. So the answer is the limit as x approaches -1 of x minus 1 is equal to -2. But x cannot equal -1 because, as we saw when I first started the problem, we are not able to determine the actual y-coordinate as x approaches -1 from both the left-hand side or from the more negative side and from the right-hand side or the more positive side. So let's actually do another problem. See, so we have, let's scroll up here, so we have the limit as x approaches 4 of x minus 4 over x squared minus 16. So it's the same thing. If you wanted to do it numerically, you'll get 0 over 0. So let's just show it out here. So we get 4 minus 4. So 4 squared is 16 minus 16. And then simplify it out, you get the indeterminate form of 0 over 0. The next thing you need to do is, like we did in this problem up here, is we need to solve it. We need to actually solve it analytically. So we write equals to the limit as x approaches 4 of x minus 4. And this time we are trying to simplify out the denominator. And how do we do that? We just expand it to x plus 4 and x minus 4. And can we simplify it out anymore? Yes, we can. We can cross out the x minus 4 on top and the x minus 4 on the bottom. And that will leave us with the limit as x approaches 4 of 1 over x plus 4. And if you were to simplify that out, you get 1/8. Alright, so the answer for this one is the limit as x approaches 4 of 1 over x plus 4 equals 1/8. But x cannot equal 4 because, as we saw earlier, we are not able to determine what the y-coordinate is when x is 4. Alright, so now let's move on to one more problem, which is going to be a little bit more difficult because this kind of got your, for this next problem it's going to be you're going to have to factor on the top and on the bottom. So we have the limit as x approaches -3 of x squared plus x minus 6, all that is over x squared minus 9. So if you were to plug in numerically, -3 squared is 6 plus 3. Hold on. So we get -3 squared is 9 plus a -3, which is 6. Minus 6 is 0. So let's just write 0 over. So -3 squared is 9. Minus 9 is 0. So you get that indeterminate form again. So let's solve it analytically like we have been with the last two problems. We need to write equals to the limit of x as x approaches -3 of. So how can we factor the numerator of, which is x squared plus x minus 6? We can simplify that down to x plus 3 and x minus 2. Let's just I'll show you how to do that real quick. So to put it back into the longer form. So we have x plus 3 and x minus 2. So this is the foiling technique. So you're going to do multiply x by x and then by negative 2. So it's going to be x squared minus 2x and then multiply 3 by x and by negative 2. So it's going to be plus 3x minus 2. I bet it's not 2, it's 6. So now you just combine like terms. So we have x squared minus 6x, actually plus x, my bad, plus x minus 6. So that's the same, actually that's plus x, my bad. So it's the same thing as we got in the original problem. Actually, let's do this real quick. Delete. And then how can we simplify the denominator? So it's simply the same thing. It's x plus 3 and x minus 3. That, the denominator is a perfect square. Perfect square is basically you have the x value squared minus an actual perfect square, which is, in this case, is 9. And whatever, if it's like x squared minus 16, it's, you just do x plus 4 and x minus 4. So it's basically x plus the square root of that number times the x minus that same square root of the perfect square. So, continuing on, can we simplify this second term down any farther? Yes, so you can. You can cross out the x plus 3 on the top and the x plus 3 on the bottom. That will leave us with the limit as x approaches negative 3 of x minus 2 over x minus 3. Now, since we can't simplify it out anymore, we can actually plug and chug like we did in the other problems. So, what is negative 3 minus 2? That is negative 5. And what is negative 3 minus 3? That is negative 6. So, negative 5 over negative 6, so a negative divided by a negative is a positive. So the answer is the limit as x approaches negative 3 of x minus 2 over x minus 3 is equal to 5/6, but x cannot equal negative 3. Alright, so that was how to solve limits analytically. We have done 3 problems. We've done the limit as x approaches negative 1 of x squared minus 1 over x plus 1. We got that to equal negative 2, except when x is negative 1. We did the limit as x approaches 4 of x minus 4 over x squared minus 16. And we get that to simplify down to the answer being 1/8, except when x is equal to 4. And then finally we did the limit as x approaches negative 3 of x squared plus x minus 6 over x squared minus 9. And we got that to simplify down to 5/6, except when x is equal to negative 3. So, like I said, that's how you pretty much evaluate limits analytically. If you have any other questions or if you would like me to do other videos based on limits, let me know in the comments below and I will get to your questions and I might make another video about limits soon. Thank you guys and come back soon.